Question number 4. We've been given a table of r prime, which is the radius, the change in the radius of centimeters per day, and the t is days. So it says here an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The base of the radius, the radius of the base of the cone is given by twice differentiable function r. So the r value that we're talking about here talks about the radius, and we've been given r prime, so it's a change in the radius in centimeters per day. Now it says it's a twice differentiable function, which means that r prime must be smooth and continuous, and this is going to be important. Where r of t is measured in centimeters and t is in days. The table above gives selected values of r prime, which is the rate of change of the radius. So r prime is our rate of change of radius. And this gives us over a time interval 0 to 12. So part A says approximate r double prime at 8.5 using the average rate of change of r prime over the interval 7 to 10. So basically the average rate of change is the average slope of r prime. So the r double prime is the slope of r prime. So I'm going to calculate the slope of r prime, which is r double prime of t. And we're going to do this in the interval here. I'm just going to highlight this interval between t is 7 and 10. Because what that does then is it takes the secant slope from 7 to 10. And since 8.5 is kind of in the middle of 7 and 10, we will say that that secant slope is equivalent to the average rate of change. Okay, and although it's an approximation because we're using these tabular values. Okay, so we're going to calculate this value here. So r double prime of t at 8.5 is equal to r prime at 8, sorry, r prime at 10 minus r prime at 7 over 10 minus 7. And so we get here, when we take a look at this value, it's going to be negative 3.8 minus negative 4.4 all over 3. So when we subtract it, we get positive 0.6 over 3. So the average rate of change, or r double prime at 8.5, is approximately, we're going to approximate it using this 0.2, and this is going to be centimeters per second, per day, or day squared. Part B says, is there time between t equals 0 and 3 for which r prime is equal to negative 6? And justify your answer. So we know that the r prime value is equal to, we've been given r prime values in the table, and we know that this is the r prime, since r is twice differentiable, r prime must be smooth and continuous. So if we take a look at between 0 and 3, we're going from negative 6.1 to negative 5.0. That means that at some point, we're going to cross r equals negative 6. So we're using the intermediate value theorem. Now, to use the intermediate value theorem, first of all, we need to establish the condition. We need to establish the condition that since r is twice differentiable, we know that r prime is smooth and continuous. Okay, now what's important is not so much the smooth part, but the continuity. Being continuous is a condition to use intermediate value theorem. So then now we can make the conclusion that by, and maybe I'll just be a bit more clear, since r prime at 0 is equal to negative 6.1, and r prime at 3 is equal to negative 5.0. Okay, by intermediate value theorem, r prime of t must equal negative 6, and this is in the interval for t is equal to between 0 and 3.